we are asked to solve for the general solution given sin 2x equals to cos x plus 45. So ladies and gentlemen, because here the angles are not the same, here we have 2x and here we have x plus 45, we cannot divide by cos. You only divide by cos if the angles are the same. So this is what we're going to do if this is the case. We are going to say, okay, I know that sine of theta, it can be written as cos of 90 degrees minus theta. This is a co-function rule, we know it, right? Which means if I have sine of 2x, I can always write it as cos of 90 degrees minus the 2x. Right? So which means sine of 2x, I can replace it with cos of 90 degrees minus 2x, which is equals to cos of x plus 45 degrees. All right? And then let me just put our grids, ladies and gents, just a quick one so that we can see. Okay, and then from here, ladies and gents, we basically have cos of A equals to cos of B. Which means if this is cos and that is cos, we can conclude that the angles are going to be the same. And this will repeat periodically for every 360 degrees because a cos function is periodic every 360 degrees. So we're going to say, therefore, 90 degrees minus 2x is equals to x plus 45. Then you must include plus 360 degrees k to show that it's repeating every 360. And then k element of z. All right, and then remember this will be the solution in quadrant 1. Cos is positive in quadrant 1. We will need to do the solution also in quadrant 4. I'll just write it here to leave a space to solve that one. In quadrant 4, we're going to have 90 degrees minus 2x is equals to, remember quadrant 4, it's negative theta, ladies and gents, right? So I can say, or let's use 360 minus rather, because this is the most common. 360 minus that angle, which is x plus 45. Remember, 360 minus theta is in the 4th quadrant. And then we write k elements of integers here, right? Right now, let's solve the first one. We can see we're going to transpose. Okay, we have minus 2, we transpose the x, which becomes minus x. This side we have 45 degrees, we transpose the 90. Then we have plus 360 degrees k. The k elements of z, write it in the first statement only. Now we know that k is an integer. We have negative 3x is equals to 45 degrees because negative 45, because 45 minus 90 is negative 45. And then plus 360 degrees k. And then we can divide everything by negative 3. Divide by negative 3, divide by negative 3, divide by negative 3. So we're left with x is equals to 15 degrees. On the 360k, even when you divide by the negative, we always say plus. And then that will be 120k. The reason we always put a plus is because the k is an integer. It's both negative and positive. So that negative is accounted for by k. So you always say plus, regardless of what sign you are dividing with. Okay, let's go on. This side we're going to have 90 degrees minus 2x is equals to 360 degrees. We substitute, we FOIL the negative x, so negative x, negative 45 plus 360 degrees k. Okay. And then we're going to have minus 2x. We transpose the minus x to become plus. This side we have negative 90 after I transposed it. This one, right? And then plus 360 degrees minus 45 plus 360k. Then let's see what will that give us on a calculator. We have minus 90 plus 360 minus 45. It's negative 225. I mean positive 225. This side you have negative x equals to 225 plus 360k. We divide everything by negative 1 to make our x positive, and then that is negative 225 plus 360k, because division by 1 is just the same thing that you're dividing. Right, and that is your general solution. Thank you very much, ladies and gentlemen.